Video, we're going to define inverse trigonometric functions, and this video is not going to be a lot of math but more concepts and thinking, so you might see this black screen for a little while, but that is what we are looking at because again this is a more concept-like video than it is about actually doing math, so I had to sniffle my nose. Alright, so how can we derive the inverse trigonometric functions and why use a trigonometric function? So for the relation to be a function, each value in the domain can have only one output. Remember that. So if we had, and we've looked at this before in other videos, but for it to be a function, one input to one output. And if we look at a sine wave, that's not exactly straight. There we go. If we look at a sine wave, then what we are looking at is a one-to-one. I know there's a little dot there. I'll get to it. I'll erase it. I'm going to go a little bit this way. Get my magic eraser. Bam. And then what we're going to look at, we're just going to look at the sine wave. Let's see if I could get this. Kind of goes up, down, up. This keeps going down and then up and then on forever that way. All right, so if I'm looking at this, we do have a one-to-one. When I look at this component here, we have this one output here. One input, one output. But if I were to take the inverse of this, we kind of lose that. So we're just going to look at this within a section. We're going to look at this between the minimum here on the left hand side, which is negative pi over 2, and the maximum on the other side, which is positive pi over 2. Doop, 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 doop. Come over here. So this is the domain we're going to be looking at, because after this it just kind of repeats itself over and over again. And we have one input for one output. So it must map each value in the range of the official function to only one value in the domain of the original function. By definition, the sine function is periodic, so the values of the range repeat throughout the domain. To create a valid inverse function, we're going to restrict our domain, and we restricted our domain between negative pi over 2 and pi over 2. And you could do this over and over again. We could even restrict our domain up to this point here, which is pi over 2 to 3 pi over 2, but we're just going to look kind of around the origin. We're going to use that origin as our place of reference. All right, so the inverse function can be defined as y equals sine to the negative 1. And remember, we use this negative 1 to denote that we are working with the inverse. If I have sine of negative 1 of sine x, this will just equal x, because an inverse undoes the actual function. So why are inverses important? Well, like I just said, inverses undo the function. So let's say that I'm looking at the inverse here. This is 1, 0. If I'm looking at the inverse, 1, 0, negative 1, 0, negative 1, that means we're going to be negative 1 and 0 here. And then this is 1, 0 here. This is not a 1, but basically you get the point. So basically this would be the angle, this would be the angle, this would be the output. And what we would see here is that if I take sine of x, this would equal the angle. And so given the angle, the sine function outputs the y-coordinate where the terminal side of the angle in standard position intersects the unit circle. The inverse sine function allows you to input the value of the output. So I could put in, let's say I'm looking for sine of theta of, I don't know, I'm going to do square root of 2 over 2. We already know this one, but I'm just going to say, I want to know what theta is. I don't know what theta is. So I can actually take the inverse sine the inverse of the square root of 2 over 2, and that's going to give me theta, because again each side would get the inverse sine, and this would be left with theta and equal to sine inverse of the square root of 2 over 2. The inverse sine function allows you to input the value of the output and the original function from a limited range of the sine function and obtain the measure of the angle. Alright guys, so this is the inverse. The same thing goes along with cosine. Your domain will be a little bit different from cosine since cosine does start above and goes below, but you're looking at the same thing. Alright guys, so this is define the inverse trigonometric function. And if you have any questions or comments, always feel free to ask. Again, this is more of a concept video than an actual working example video. So if you have any questions or comments, always feel free to ask, and I'll catch you in the next video.